What we're going to be doing in this video is calculating tide times and heights for non-standard ports. Now, non-standard ports are not standard ports as non-standard ports suggests, okay? Non-standard ports are located within standard ports, okay? And we've suggested a couple of standard ports within Queensland, like the Gold Coast Seaway, Brisbane Bar, Mooloolaba, Noosa Heads, places like that. And non-standard ports are located within those ports. So, for example, the standard port of Noosa Heads has several non-standard ports within it, such as Munna Point or Toolwanton are part of the standard port of Noosa Heads. So this is the process of calculating the tide, time and heights for those non-standard ports. The first thing that we need to do in completing this particular document, parts A, B and C, is some supplementary documentation which we can get from our tide timetables, and that's what I've gone and done for the standard port of Noosa Head. Now this here is the 2017 tide timetable for the standard port of Noosa Head, okay? And just to help you out, I will write standard port, okay, because that is important. Now, with regards to the date that we're going to use, today's date is the 2nd, which is here, okay, but I'm not going to use today's date. The reason being is because on today's date, coincidentally, there are only 3 tides today, which means we're going to have a column that's left out. Now, it doesn't mean that we could not complete this table with regards to today's date. It just means that the final column is going to be blank because this tide does not actually exist for today. Okay, so what we might actually do is do the 3rd of the 2nd, which will be tomorrow. Okay, now that being a Friday. Now, the place in which we're going to determine the time and heights for with regards to tides and the non-standard port is going to be Munna Point. However, for box A, we are required to put in the data for the standard port of Munna Point. Now, the standard port of Munna Point is Noosa Heads. So the place is the standard port, which is Noosa Heads. Okay? Once we've established the standard port and the date, we then go to our tide timetables and we get the information for that standard port, being Noosa Head, and the date in particular, which I'm going to circle this time around, for the 3rd. And I simply am going to copy the times into the time and the heights into the height. I'm just going to move back to the side and do that. So we've got 0016, 0615, 1225 and 1904. Okay, if you want to quickly have a look, I got those values, as I said, from the times, and now I'm going to put in the heights, okay, in this column. 1.61, 0.74, 1.69 and 0.58. Okay, we've now got our heights filled in and we've completed the first table, table A. Okay, so we've done table A. Right, that's done. Moving on to table B. Okay, we are now looking at the non-standard port, which our non-standard port we suggested is going to be Munna Point for this particular question. The date is still the same date, the 3rd of the 2nd, 2017, which is tomorrow being a Friday. Okay, and what we need to firstly identify once we've done this information is the high and low tides. We do this by noting the height in this table A. No, this is higher than this, and this is higher than that, which means we've got a high, low, high, low. So we order them as such just by circling whether or not it was a high or a low tide. The standard port times, note standard port times is part of part A, okay, where we talk about the standard port, not the non-standard port. Okay, so the standard port times are these times up here, which we're simply going to list across in the first column. Now be careful, make a note that you want to leave enough room for 1, 2, 3 lines of working, okay, and your answer is going to be the final fourth one in this box. So 3 lines, 1, 2, 3, make sure you leave yourself enough room. So we're going to put these times in. We've got 0016, 0615, 1225 and 1904. So I'll put those times in for the standard port times. I then look down and it says average time difference from table 2, column 2 and 1. Now that data comes from another supplementary piece of supporting evidence or documentation, which is our semi-diurnal tidal planes for same year 2017. Okay, now what these show are standard ports. This is Mooloolaba, Noosa Heads, which is the one we're interested in, Waddy Point being Fraser Island, Urangan and Bundaberg. Now if we look at the standard point in Noosa Head, we can find Munna Point. Okay, and Munna Point, if we go to column 2 and column 1, we have these numbers here referring to a HW and an LW time difference. Now this refers to the time difference at Munna Point for a high water and for a low water. Now this one is plus 42 and this one is plus 1 hour and 35, which means that for every high water at Noosa Heads we have to add 42 minutes to get the equivalent high water for Munna Point. Alternatively, every low water at Noosa Heads we need to add 1 hour and 35 minutes to get the equivalent low water at Munna Point. Okay, so that's what we're going to use this information for. So where it says back on the table, average time difference, that's where we're going to note for the high water marks, we said we add 42 minutes. So we add 0 hours and 42 minutes. And for the low water, we add 1 hour and 35 minutes. High water, 42 minutes. Low water, 1 hour and 35 minutes. Okay, what we need to do to the 42s and the 135s, for both of these values, for both highs and lows, they need to be added because it says in the data that they both need to be plus and plus. Okay, you'll get instances like this one down here for Tin Can Bay where you've got one that's plus and one that's a minus, so you have to be careful when you do that over here. So I'm actually going to write plus, 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 just to make it a bit more explicit in the process of filling this table out that I need to add these things together. Okay, it's always handy to have a calculator, but you can do these in your head a lot of the time. 6 and 2 is 8, 4 and 1 is 5, 0 and 0. 5 and 5 is 10, carry your 1. 3, 1 and 1 is 5, 6 and 1 is 7, carry, and 0 is 0. 7, 6, 2, 1, 9, 3, 0, 1, 2. Okay. Now, what I'm going to do as a final step is put those times down here. Okay. Now, what you'll notice, some of the times that I've just calculated don't need to be changed. For instance, 0058 is 0058. Okay. 0750 is 0750. But for the next one, you know, 1267, you don't often get a time expressed as such where the minutes exceed that of 60. Okay. So what we need to do is convert this to an hour and bring it over to add to the hours. So what we'll have is 13 hours with 7 minutes remaining, okay, which is 107. This 2039, 39 minutes, nothing wrong with that, is 2039. So there's our times done. We then need to go through and start completing the heights, which is more or less the same process as this table here, except instead of putting the times across like so, we're going to put the heights from the standard port across like so. Once again, high, low, high, low. These times here refer to this height. So if it's high here, it's high here. If it's low here, it's low here. Standard port heights from the table, we've got 161, 074, 169, 058. Alright, ratio, you'll know, is something that we're going to have to multiply. Okay, so we're going to multiply a ratio to these numbers. Where we get that ratio is from table 2, column 9, which is back to the semi-diagonal tide planes. And we go to the ratio column 9, and we scroll down to Mana Point, and we get to this number here, 0.40. Okay, this is 0.40. So what we need to do is multiply this number by all of those standard port heights. So ratio multiply, we simply write 0, 40, 0, 40, 0, 40, 0, 40, and to show what we're going to do, I'm going to multiply. Okay, so I need to multiply these two numbers together to get a result. To do that, use a calculator. It's going to save you a heap of time. 1.61 by 0.4 is 0.644. Okay, 0.74 by 0.4 is equal to 0.296. 1.69 by 0.4 is equal to 0.676. And 0.58 by 0.4 is equal to 0.232. Okay? Now you'll note I've left enough room to write another number underneath, and that's because I have to put another adjustment. Okay? And that's from table 2, column 10 this time. Okay? Column 10. So I bring across my semi-diagonal tide planes again from Mana Point, and I go to my column 10 and down to Mana Point, and I get plus 0.13. Plus 0.13 for the column 10. And I need to add that to the value in which I've just obtained. So for every single one, I'm going to add 0.13, 0.13, 0.13, 0.13. Okay, and if I add those to the original result, I should get the following: 4, 7, 7, 0, 6, 2, 1, 4, 0, 6, 0, 8, 0, and finally 2, 6, 3, 0. To show a little bit more easily what I'm adding together, if I want to put a line like so just above the previous calculation, which was the ratio, you can see a little bit more easily that these two things need to be added and these two things. Okay, so these are the two numbers that we're going to have to add together. We're not actually adding these three, we're only adding the last two, okay, to get these results. Once we're there, we've done the final part of part B, and we can move on to part C, which is the height of a tide at any given time. Okay, so what these show is essentially the times, 2, 3, 4 times for the 4 changes of tide. So high, low, there's your high, your low, your high, your low, and the times in which they occur. Now if we wanted to find the height of a tide at an intermediate between these two times, this is what this table sees for. Okay, so let's suggest the height of a tide at a given time. I'm going to suggest the time is 0400 hours. Okay, now just looking at that time, if this is approximately 1 o'clock and this is approximately 8 o'clock, this 400 hours is in between at 4 AM. Okay, so somewhere in between that low, or that high and that low. Now once you've written this in, you can continue writing this into several different places in this table. What I mean by that is the time required here is also the time which we just wrote. So we can simply go 0400. Once again down here, the time is also 0400 hours. And there is one more height at 0400 hours. So we can straight up go and throw them in. Okay, the place is for the non-standard port being runner point. Okay, and the date is still the 3rd of the 2nd, 2017. So you can see I can fill a lot of this stuff out without really having to do anything. The nearest high water is the nearest high water to 4 o'clock. And as I said, 4 o'clock lies within here. So the high water that's nearest it is this one. Okay, and the time in which it occurs is 0058. So we write in 0058. Okay, and essentially what we then want to do is determine the approximate hourly interval. So if this was 1 o'clock, there's approximately 3 hours separating. Alright, the 2 minutes isn't going to cause too much of a drama. Okay, so if you want, you can just say that approximately hourly interval is 0300 for 3 hours, okay? The nearest high water, okay, the nearest high water we've suggested occurs at this time, 0058. But the height in metres at that time is 0.774. So we can put our 0.774 over here, and we note the nearest low water is going to be this one. Okay, and if we scroll down to the height at which it occurs is 0.426, so 0.426, like so. Once we've got that, we have to then determine the range. Now the range in mathematics is simply the difference between the high and the low. So we simply take the small one from the big one. So 0.774 take away 0.426 is equal to 0.348. 0.348. Okay. Now the height of the low water, okay, the height of the nearest low water, we've just suggested is 0.426. So we can put in our 0.426 as the height of the low water. Now the last thing that we need to determine is this height from a graph. Okay. Now this height from a graph can be a little bit tricky at times, but it is simply read from a online graph which you can access from your tide timetables. Okay, 1 second. And I'm back with the graph. So, my apologies for that. What we have is the graphs that we need to utilise to finally come up with this number, being the height from graph 1 or 2. Okay, so what we need for, to determine this height from graph 1 or 2 are these two values. I'm going to circle them, okay, because they are important. The 3 and the 0.348. So we need the approximately hourly interval and the range. They're the key things that we need to use. Now you'll note that the range is 0.348, okay? We have two graphs that we utilise. For the most part, tide ranges up to 6 metres we don't worry about because we don't often experience that in southeast Queensland. We experience tidal ranges up to 3 metres. So this is the graph that we're going to use. Now how we go about using this graph with regards to the values that we just calculated is just like this. Okay, well, down the bottom we have hourly interval from nearest high water. So what we need to do is locate the hourly interval over here, which is our 3. Okay, so here's a 3, a positive 3, as well as a negative 3. Now what you'll note is because these curves are symmetrical, it does not matter whether you use a negative 3 or a positive 3, which is why they're both there and they're both valid to use. Okay, I'm just going to say the positive 3. Okay, so this is where we're going to have to look at with regards to the x-axis, and with the range you'll note a range of 0.35 approximately, 0.35 let's say, would lie below a range of 0.5 metres, which is this here. So 0.5 is approximately there. Okay, so what I'm essentially going to try to do is I want to draw in a new range curve which is going to represent the 0.35, which you'd agree would occur somewhere below the 0.5 metre range curve. It might be there where I'm suggesting. Okay. Now it's hard to see what I've just drawn in because this is a pencil. Alright, but what you then essentially are going to do is match that 3 up to wherever it intersects that range curve. And let's just assume it intersected there. Okay, so let's say the range curve for 0.35 came down, intersected the 3 there. Okay. What we do is at that point we move across to the y-axis and look at the nominated value in which it's suggesting, which is this 0.2. Okay, now that 0.2 is the height from graph 1, which is the value here which we're going to insert. Okay, so this 0.2 is the height from graph 1. Once again, the process is this. Hourly interval from nearest high water, we take this number here, the approx hourly interval. Alright, 3 hours. We also take the range and we assume a range curve on this particular graph. Okay, and as I said, 0.35 would fall in somewhere there. Alright, something like this. We then match that 3 to where it intersects with the range curve we just drew in, and we go across to the y-axis like this, and we note the value on the y, and in this instance it's 0.2. So I'm simply going to write 0.2. Okay, and to get the final result being the height of the tide at that 400 hours, okay, 400 hours, the height at that time, we have to add these two things together. Okay, so we're going to add those two together, which will give us a 6, a 2, and a 6, and we can put in our units in metres. Okay, so 0.626 metres is what I would expect the height of the tide to be at Mana Point at approximately 4 o'clock in the morning. If you want to see, or if you just want to check if it's if you want to check if it's an approximate answer, such that you're in the right ballpark, the easiest way to do that, I think, is to note that 0400 hours we suggested exists between these two times, okay, which means that it exists between these two heights, being 0.774 and 0.426. So the tide's somewhere between there, which means the height of the tide between there is going to be between those two numbers. Alright, and if we look at this number down here, it's definitely between these two numbers. Now if this was bigger than 0.774 or less than 0.426, then something has gone horrifically wrong, okay? Because 400 hours is between these two tides, which means it needs to be between those two heights. Okay, so just by looking at that as from a glance, I can suggest that it's in the ballpark, and based upon the process that I've used, I would suggest that there is correct. So that there is the process we use to complete one of these non-standard tide times and height tables. All right, and as I said, you need to have some supporting documents with you, being our semi-diurnal tide planes, the raw data with regards to standard port times and heights, and last but certainly not least, access to the standard tidal curve with regards to ranges up to 3 metres.